Okay, let's do, this is take two, because this is my zombie class. So, Ava's in my zombie class. She's a little zombie-like in the morning, okay? But she smiles, so she's a smiling zombie. She's not a scary zombie. Okay, so, Mohammed came up with a suggestion that we're gonna do a combined gas law problem. Mohammed, do you have anything specific in mind, or you want me to pick something, or what would you like to do? Anything? I'll pick something? Okay. All right, take this data down. Let's make up a problem. Okay? All right. There is a gas. There's 10 liters of a gas. Musabi, you're going to take this down. Zombies can write, believe it or not. They can write. Exactly. You can put your book on his desk. That's okay. That's not a problem. But zombies can write, contrary to popular belief. And zombies can do chemistry. It's one of the few things zombies can do. Zombies are very good at chemistry, so there's no excuse. Excellent. Jen, that's a very good zombie look. She's rocking back and forth, staring at me. It's a little scary, actually. So, so there's a gas. There's 4 liters of a gas. No, 10 liters. Let's say 10 liters of a gas. And that gas is at 1 atmosphere. It's 1 atmosphere. Yes? Okay. Now, and it's 0 degrees Celsius. Okay? Now, I want to compress that gas so that it's 1 liter, right? But at the same time, I want the gas to be heated to 100 degrees Celsius, okay? I want to know what the new pressure is going to be, but I want to know what the new pressure is going to be in atmospheres and kilopascals. Is that a really cool problem or what? Okay, so we have P1, V1, T1. When I've been doing this my entire adult life, I've been doing chemistry. Isn't that a little scary? And I'm 58. That's 40 years of chemistry. Okay. I'm celebrating my 40th year of chemistry this year. It's a little scary, don't you think? A little scary? Okay. So, those are the conditions. And I even do the problems like this. When I do it on paper, I write it down because I just get too baffled. Or as we say, überboodled. Okay? So, all right, so what's the data that I said? We've got to interpret. This is kind of like a word problem. Kinga, how you doing back there? You all right? My Polish zombie. She's very quiet. She actually makes a very good zombie. Very calm. Doesn't chase people around. Very sweet. Yes? 371.1. You actually did the problem?
Yes.
Okay. Wow. See, I told you zombies can do chemistry. You didn't believe me. Okay, so what's P1? 1 atmosphere, right?
Yep.
Is that correct? What's V1? 10 liters, right? And the temperature is 0 degrees Celsius or 273 K. Right? Yes? Okay. Now, P2 we're looking for, right? We're looking for in atmospheres, and we're looking for it in kilopascals, right? So V2 is going to be 1 liter. Is that what we said? We're going to compress it down to 1 liter, and we're going to heat it at the same time. Just that information, what do you think the pressure is going to be? Higher, lower, a lot higher, a lot lower? What do you think?
Much higher than
Much higher, because not only are we compressing it, but the gas is going to get heated. So Gay-Lussac's law, right? Increased temperature, increased pressure, right? And Boyle's law, decreased volume, increased pressure, correct? Are you there? Excellent. Okay. So T2 was 100 degrees Celsius, right? And that's going to be 373 K. Okay, good. So now let's put it in the, yes, Jen.
I did the problem wrong. It's actually 1,884.1.
Okay, well that's okay. Zombies make mistakes, but they recover and learn from them. Excellent. Okay, enough of the zombie stuff. Okay, good. You guys are starting to come to life. I like it. Okay, so I'm going to say PV over T equals P2 V2 over T2. Right? Is that right? Is that on the camera? Yes? We cool with that? Okay, so now what? Let's plug in. 1 atmosphere times 10 liters divided by 273K equals P2 is what we're looking for. V2 is going to be 1 liter. Kind of makes it easier, doesn't it? And then over 373K. All right, so in terms of atmospheres, 1 times 10 is 10, times this is going to be 3730, right? Divided by 1 times this is going to be 273. What does that equal? About 11-ish? 12-ish? What does it equal? 13. Can we just say 14? Is that all right? That's a lot of round off error, but that's all right. 14 atmospheres, right? Now let's review. Let's review, shall we? Can we do? No. Let's finish the problem. I'm so excited. Now, how would you do it in kilopascals? Remember, 1 atmosphere is 101.3, right? So how many would 14 be? So how do you get that? How do you convert 14 atmospheres into kilopascals? Think. Don't convert, think first, right? 14 atmospheres, each atmosphere is 101.3. What would I do to 14 and 101.3? Would I multiply them, divide them? Yes. I would multiply them, right? Okay. And what would you get? If I'm going to multiply 14 times 101.3, it's going to be like 1,400. It's going to be 1,418.2. Is that right? Yes? Now, let's remember what that means. Okay? Now, you ready? Let's review. Remember, can I erase some of this stuff? Musaba, can you get me some paper towels, please? Like a lot of them. Would you do that, please, for me? You're a wonderful person. God bless you always. Okay, now, let's take a box, okay? Box like this big, so a meter, 1 meter long, right? Yes? You with me, Ellen? 1 meter long, yes? 1 meter wide, right? And 1 meter deep. Can you picture the box right here? It's a box that's 1 cubic meter, right? If I fill that with water, right? How much is that? How much water is that going to be? How much water am I going to be able to put in there? Any ideas? I can put 1,000 liters. I can put 1,000 liters in that box. What's the mass of each liter?
1 kilogram.
1 kilogram. So how many kilograms can I put in that box? 1,000, right? Because each liter's a kilogram. So 1,000 kilograms, correct? Yes? So it's 1,000 kilograms per cubic meter. You think? Is that right? Yes? Okay. Yeah? You all right with that? How did I get that? Should I show you? I will. Just give me a second here. So now what's the pressure? What's the pressure of that box? Pressure is force per square meter, right? So what's the pressure of that box? What's the force? Remember how we get force? Force equals what? Do you remember? Force equals mass times acceleration, right? Oh, he's wonderful. I love it. Thank you. All right. So do you remember what force is? Force is what? Force is mass times acceleration. So that's going to be 1,000, what? 1,000, and what's the acceleration?
9.8.
Gravity, 9.8. We'll just say 10. Is that okay? Is that okay? So 10, that's going to be 10,000 kilogram meters per second squared.
2,000 newtons.
Right, exactly. This kilogram meters per second squared is the same thing, defined as 3 parallel lines. Did you know that? It's a mathematical thing. A Newton. Is the word Newton named after a cookie or a person? A person.
You said Newton.
Right. All my students usually say, why is it the same thing as a fig Newton? You ever hear of a fig Newton? Any Americans hear of fig Newton? One. I have one person in this class, 2 people in this class who have ever heard of a fig Newton. That's amazing. International education, I love it. Love it. Love it. So, so it's a Newton, right? So it's going to be 10,000. This box is 10,000 newtons per square meter, right? Now, how many square meters, I'm sorry, what is Newton per meter squared? What does that mean? Well, there's a word for that. Just like this was newtons. What is Newton per square meter?
Pascal.
A Pascal, exactly. Newton meter squared is a... Now, is a Pascal, what does the word Pascal come from? Look it up. Where does the word, you know this. I know this is my zombie class, but I've said this. The people who are looking at this video all over the world are thinking, what kind of class does he have? They don't know what the word Pascal is? And this is a review? All right, we'll wait for that and we'll continue. We'll get some answers on what Pascal is. A little weird. So it's going to be a Pascal. So it's going to be 10,000 pascals, right? Correct? Or 10 kilopascals, right? Now, what is the atmospheric pressure? What's standard pressure in pascals? Yes. Approximately 100. Would you say? Yeah, 101.3. Approximately, we'll round it to 100. Is that okay? So we're going to say standard pressure. Standard pressure. Can you read that on the video? Does that come up? Does that come up? It doesn't come up? Can you just straighten that out a little bit there, Kamal? My videographer from Palestine. I love it. Excellent. Palestinians, God bless them all. Okay. So we have standard pressure is 100 kilopascals. Right? So, how many of those boxes would I stack on top of each other total? What is the total number of boxes that I would stack one on top of another? 10. That's a lot of boxes. Can you imagine being under that? Can you imagine? I mean, 1,000 kilograms each one. How many pounds is that? That's a ton. And each box is a metric ton. 2,200 pounds is a metric ton. Isn't that amazing? Can you imagine being under 10 of them? Well, you are right now. You're under 10 of them. Oh, no! Help me, no! you're under 10 of them. Amazing, isn't it? Yes? Pretty cool, huh? Don't you think? Yeah? Pretty cool. Yeah. So, you get it? Yes? Remember I said I would show you, well, how do you get 1,000 liters in that box? I kind of glossed over that, didn't I? Didn't I? How do you do that? Right? Well, let's see. Let's see, shall we? Okay. We have 1 meter cubed. Is that correct? Yes or no? Shall I make that bigger? How far is it coming over here? You're under, okay, we're fine. So I have 1 cubic meter. Let's convert that volume to cubic centimeters. Is that okay? Can we do that? Okay. All right, so that's going to be cubic meters. So what's it going to be? How many centimeters in a cubic meter? How many cubic centimeters in a cubic meter? How many cubic centimeters in a cubic meter? How many centimeters?
100,000.
So I have, don't I have 100 centimeters in 1 meter? Don't I? Yes or no? Okay. I'm going to cube that whole thing. So aren't you going to cube all of the factors? What factors are here? 10 squared. Isn't centimeters a factor? Yes? 1 is a factor. M is a factor. So in other words, I have this rule. Can I run over here? Where does this end?
Doesn't show.
Yeah, it didn't show.
Doesn't show up, so
So,
to the left.
you're on
You're on the line.
Right there? Okay. So isn't it true, A over B, P, D, right? Raised to the n, that equals A to the P n over B to the dn. Isn't that true? So I'm going to multiply all the factors, right? You get that? You know that though, right? Okay, good. So let me write down here, I'll bring over this, and this will be
10 to the 6.
10 to the 6th, right? What's 10 to the 6th? A million, yeah.
Centimeters
Cubed over 1 meter cubed. Is that cool? Are we cool with that? So what's 1 times 10 to the 6th? A million, right? Cubic meters cancels. So what am I left with? Can I write up here? I'll write up here. Here, can I erase this? Can I erase this? Is that right? So I have 1 right? Yes? Now let's convert that to liters, okay? But we're not going to do a brainless conversion with multiplying and all that kind of stuff. We're going to think, okay? How many cubic centimeters are there in a liter?
1,000.
1,000. Do you understand that? Massa, did you know that? Like that? You didn't? Okay, good. You ready? How many milliliters are there in a liter?
1,000.
1,000 milliliters in a liter, right?
1,000.
Massa, true or false? 1 milliliter equals 1 cubic centimeter. True? Okay, good. So 1 milliliter equals 1 cubic centimeter. Right? Right? So in 1 liter, I have 1,000 milliliters, right? So in 1 liter, I have 1,000 cubic centimeters, right? So how many thousand go into 1 million?
1,000.
How many thousand go into that? How many thousand can I get out of 1 million? Right? How many? How many? 1,000. So there's 1,000 liters. So 1 cubic meter equals 1 million cubic centimeters equals 1,000 liters. You get it? You get it? Excellent. Excellent. She's smiling. I love smiling zombies. She's my Jordanian zombie. I like it. Excellent. Well done. How many people love zombie movies? Raise your hand. You can tell because everybody, it's like everybody wants to be a zombie. It's like really cool. Can you imagine being in a movie as a zombie? Wouldn't that be really cool? Get dressed up and, yeah. You've been a zombie before?
I was a zombie 2 years in a row.
You were a zombie 2 years ago? Where?
2 years in a row.
2 years in a row. Excellent.
I was a zombie last year. I was a Red Riding Hood zombie.
You were a Red Riding Hood zombie, so you're kind of mixing up the old generic zombie with a specific zombie.
And then
I like that. Very
I
creative.
was just a random zombie that got eaten.
You were just a random zombie that was partially eaten.
Yes.
Excellent. I like that. A random zombie partially eaten. I like your creativity. Excellent. Now, does Denmark allow zombies? Do they have these zombie laws where all zombies and humans are created equal or anything like that? Excellent. I like it. Very forward-thinking country, Denmark. Excellent. Thank you. Excellent. So now, so what are we going to do next? Shall we quit this video and make another one? So what was this video called? This video was called, I don't know, Test Review 1.
Yeah.
Is that cool? Test Review 1, 2014. Yeah? Are we cool with that? We're off.